This video, let us learn how to read or calculate the value of a capacitor. Now if you see here, these are the different types of capacitors like tantalum capacitor, aluminum capacitor, ceramic capacitor, trimmer capacitor and thin film capacitor. Now coming to the capacitor value. Generally, the values of capacitor are measured in microfarad, nanofarad and picofarad. And the value of 1 microfarad is 10 to the power of minus 6 farads, and the value of 1 nanofarad is 10 to the power of minus 9 farads, and the value of 1 picofarad is 10 to the power of minus 12 farads. Now let us see one by one in detail. Next is electrolytic capacitors. Generally, the electrolytic capacitors are divided into two types, which are wet aluminum electrolytic capacitor and the second is axial electrolytic capacitor. Now, in these two types of capacitors, the values of capacitance and the voltage are already printed on the capacitor. Now, let us see them. This is an example for the wet aluminum electrolytic capacitor, in which the value of the capacitor is printed as 220 microfarad and the value of the voltage is printed as 25 volts. And if you see here, this white strip indicates the negative terminal and this side indicates the positive terminal. Now coming to the axial electrolytic capacitor. These are the examples for the axial electrolytic capacitor, in which the value of the capacitance is given as 10 microfarad and the value of voltage is 500 volts. Now this is the another type of electrolytic capacitor, in which the value of voltage is printed as 40 volts and the value of capacitance is printed as 2000 microfarad. Next is tantalum electrolytic capacitor. In this type of capacitor, the value of capacitance and the value of voltage are already printed on the capacitor. Now if you see here, the value of capacitance is printed as 4.7 microfarad and the value of voltage is printed as 35 volts, and these two leads represents the negative and the positive terminals. Now for an example, if the value on the tantalum capacitor is printed as N61, then the value of the capacitance is 0.61 nanofarad, and if it is printed as 5U2, then the value of the capacitance is 5.2 microfarad. That means the letter N indicates nanofarad and the letter U indicates microfarad. Next is ceramic capacitors. Now let us see a 2-digit capacitor which acts as the low voltage disc capacitors. And these are the two examples for underlined capacitors, in which the value of the capacitor is 22 picofarad with a voltage of 50 volts or 100 volts. And if you see here, for this capacitor, the value of the capacitance is 47 picofarad with the voltage as 50 volts or 100 volts. Now coming to the not underlined capacitors. These are the two examples for the not underlined capacitors, in which the value of capacitance is 10 picofarad and 47 picofarad with a voltage of 500 volts. Hence, the capacitors with the underlined capacitors have a voltage of 50 volts or 100 volts, whereas the capacitors with not underlined will have a voltage of 500 volts. Next is high voltage disc capacitors. Now if you see here, in this case of capacitors, the value is given as 151. Now the capacitance of this capacitor is 15 into 10 to the power of 1. That means the first two digits represents the value and the last digit represents the multiplier of the capacitor. That's why the value of the capacitance for this capacitor is 150 picofarad and the voltage rating which is written here is 15 kilovolts. Next is, if the capacitor is having the value written as 4R1, then the value of the capacitance is 4.1 picofarad. That means here the letter R indicates the decimal point. Next is If the capacitor is in the form of two codes, that is, the first two represents one code and the next three represents the second code. In this, the first two, which represents the first code, represents the value of the voltage, and the next three, which represents the second code, represents the value of capacitance. So if you see here, the value of the capacitance is 253 and the value of the voltage for 1A is 10 volts. Next is 3-digit capacitor. As in the same way of 2-digit capacitor, the 3-digit capacitors also have underlined capacitor and not underlined capacitor. Now coming to the underlined capacitor, if you see here, the capacitor is having 3 digits and they are 1, 0, 3. The first 2 digits represents a value and the third digit represents a multiplier. Hence the value of the capacitance is 10 nanofarad and the voltage rating for the underlined capacitor is 50 volts or 100 volts. Next is for not underlined capacitor. For the not underlined capacitor, the value of the capacitance is 10 into 10 to the power of 4, which is equal to 100 nanofarad, and as it is the not underlined capacitor, the value of the voltage is 500 volts. Next is a 3-digit capacitor with a tolerance. Now if you see here, this is a 3-digit capacitor in which the first 2 represents the value of the digit and the third one represents the multiplier and the fourth one represents the tolerance of the capacitor. And this is the table for representing the value, multiplier, letter and the tolerance. Now if we want to calculate the value of this capacitor, the value of the capacitance is 100 nanofarads. Next is, let us see an example for it. Now if you see here, the value written on the capacitor is 473J. As I said, the first 2 digits represents a value. Next, the third digit represents a multiplier. So it is 10 power 3. And the fourth one represents a tolerance. And letter J has a tolerance of plus or minus 5%. So finally, the value of this capacitance is 47 nanofarad with 50 volts or 100 volts as the voltage rating. Next is capacitor with voltage rating. Now if you see here, this is the table for representing the capacitor voltage code and this is a table for representing the different letters code and different tolerances for the codes. Now the example is 2A473J. Now here the 2A represents the voltage code and the 47 represents the value of the capacitor and 3 represents the multiplier and J represents the tolerance. So that's why the value of the capacitance is 47 nanofarads with a tolerance of plus or minus 5% and the voltage is 100 volts DC. Next is SMD capacitor coding. Now if you see, these are the different types of SMD capacitors. Now let us see how we can calculate the value of these type of SMD capacitors. The first one is SMD aluminum electrolytic capacitor. Generally, there are two forms for representing this SMD aluminum electrolytic capacitor. The first one is can style. So that's why it is SMD can style electrolytic capacitor. Now if you see in this figure, this is the representation for the can style electrolytic capacitor in which the first 2 letters represents the lot number. The next 2 digits represents the value of the capacitance. The letter C represents the voltage and the next 2 letters represents the series of the capacitor and here the black strip represents the negative terminal. And here this is a table for the representation of the letter and its voltage. Next is SMD aluminum electrolytic capacitor with an example. Now if you see in this figure, here the value of the capacitance is 220 microfarad and as I said, if there is any letter here, then that letter represents the value of the voltage. So for an example, if the letter here is V, then the value of that voltage is 35 volts. And the next 2 letters FK represents the series and here there will be a lot number for the representation of the electrolytic capacitor. Next is, these are the other forms for the representing of can style electrolytic capacitor, in which the value of the capacitance is 100 microfarad and the voltage is 50 volts. Whereas here the value of the capacitance is 220 microfarads and the value of the voltage, if the letter here is H, then the value is 50 volts. Next is the second type, which is case style electrolytic capacitor, and this will be there in the tantalum electrolytic capacitors. Now if you see the figure, we can observe that there is the positive end of the capacitor, which is a red strip of line, and the value of the capacitance is already printed on the capacitor. So it is given as 22 microfarad and the voltage is also printed on the capacitor, which is 20 volts. Next is SMD tantalum electrolytic capacitor along with the multiplier. Now if you see in this figure, the red strip here represents the positive end of the capacitor. The first two digits represents the value of the capacitance and the third digit represents the multiplier, and the letter here D represents the voltage. So the value of the capacitance is 10 into 10 to the power of 7 picofarad, which is equal to 100 microfarads, and the value of voltage is 20 volts since the letter is represented as D. Next is SMD tantalum electrolytic capacitor. This is the other type. So if you see here, the red strip over here represents the polarity of the band and this represents the logo, and here the 106 represents the value of the capacitance and the letter C represents the voltage. So finally the value of the capacitance is 10 into 10 to the power of 6 picofarad, which is equal to 10 microfarads, and the value of voltage is 16 volts since the letter is represented as C. Next is SMD ceramic capacitors. Now if you see, these are the different types of ceramic capacitors, and these ceramic capacitors are basically divided into three types, which are class 1, class 2 and class 3. Now the class 1 ceramic capacitors. The class 1 ceramic capacitors offer high stability and low losses for the resonant circuit applications. Next, class 2 ceramic capacitors. The class 2 ceramic capacitors offer high volumetric efficiency with change of capacitance lower than minus 15% to plus 15%, and its temperature range will be greater than minus 55 degrees centigrade to plus 125 degrees centigrade, and these are used for smoothing, bypass, coupling and decoupling applications of the circuits. Next is class 3 ceramic capacitors. The class 3 ceramic capacitors offer higher volumetric efficiency than the class 2 ceramic capacitors, and its typical change of capacitance is minus 22% to plus 56% over a lower temperature range of 10 degrees centigrade to 55 degrees centigrade.